When we have a video of a basaltic eruption and want to constrain some source parameters, we need an accurate length scale. But in these rapidly changing landscapes, we usually lack fixed reference points with which to compare dimensions. So we have developed a new method for determining the size of pixels in these videos, assuming that large ejected particles behave like ballistics with a parabolic path around their turning point or zenith. So the only significant force acting on them would therefore be gravity. So the first thing we do is to convert the video into frames, and we can then open these frames in ImageJ and use the mTrackJ plugin to track the clasts over successive frames around the zenith. And we can then plot the vertical position of the clast against time and fit a parabola that is associated with a second-order polynomial equation to the curve. We can then substitute the first coefficient with minus g/2 in the ballistics equation to determine a vertical scale factor, since we know the value of gravity. So we repeated this for several clasts to obtain an average for a suitable scale. So we validated this method with two analog experiments, one which simply consisted in throwing upward a plastic ball to study single class dynamics, and the other with a water fountain to study lava fountain dynamics. And both experiments were filmed with a physical scale for reference. And the scaling factors we calculated using our method showed less than 10% error compared with the real scale. So we hope this new method will be useful as an alternative approach for determining the vertical scale in videos of basaltic eruptions. Thank you.